In 2023, the James Webb Space Telescope revealed something shocking. Galaxies which were fully formed and massive were seen just 300 million years after the Big Bang. That was way too early. Astronomers like Dr. Jehan Kartal-Tip and Dr. Adam Rees were stunned. Because if galaxies already looked like this so soon after the universe began, then maybe our ideas about the beginning are wrong. What if the Big Bang wasn't the start? What if there was something before it? And what if that something was nothing? But here's the twist. Physicists like Sir Roger Penrose and Sean Carroll argue that nothing might not be empty at all. In fact, it might be more real than the universe we live in. This video isn't just about what created the universe. It's about the deeper question. What created the nothing that came before everything? And why are scientists now rethinking time, space, and reality itself? Let's find out. In 2022, astronomers using the James Webb Space Telescope made a discovery that shook the foundations of what we know about the universe. They observed ancient galaxies, far more developed than expected, with structures as mature as our own Milky Way. This suggests these galaxies existed much earlier than the Big Bang theory predicts. To understand why this matters, let's step back a century. In the early 1900s, most scientists believed the universe was static, unchanging, and eternal. But in 1912, astronomer Gustav Slipher noticed some nebulae moving away at incredible speeds. Initially, he thought this was caused by the movement of our own galaxy, but further observations disproved this. Then, in 1929, Edwin Hubble made a breakthrough. He found that the farther a galaxy is from us, the faster it moves away. This meant the universe is expanding. This expansion fit perfectly with Einstein's general theory of relativity, which describes how space-time can stretch or contract. Tracing the expansion backward leads to a tiny, dense point, called a singularity, where all matter and energy were compressed. This idea became the Big Bang theory. About 13.8 billion years ago, the universe began in a massive explosion. But what existed before the Big Bang? If space and time began then, can before even have meaning? This question challenges physics at its core. A singularity is where density and temperature become infinite, and our current physics breaks down. General relativity alone can't fully explain it. And now, with recent observations of mature ancient galaxies, we must reconsider the timeline of the universe's birth. Could there have been something before the Big Bang? Or is the Big Bang just one chapter in a much larger story? As we go deeper, we'll explore new theories, like those of Sir Roger Penrose, that challenge our understanding of nothing and the universe's true origin. If the universe formed from nothing, then who or what created that nothing? Back in the early 20th century, the universe was thought to be static, unchanging, eternal. No expansion, no contraction, just a steady, endless cosmos. Then, in 1912, astronomer Gustav Slipher made a groundbreaking observation. He noticed that many nebulae, what we now know as galaxies, were moving away from us at incredible speeds. At first, this was puzzling. Was it just our own Milky Way galaxy in motion? But further observations, especially those by Edwin Hubble in the late 1920s, confirmed a stunning truth. The farther away a galaxy was, the faster it was moving away. This discovery wasn't just a scientific milestone. It completely upended our understanding of the cosmos. It meant the universe was expanding, and by rewinding this expansion, we could trace everything back to a tiny, hot, dense point, a singularity. This singularity is what we now call the Big Bang. It marks the moment when space, time, matter, and energy all began. But what happened before that? For decades, scientists struggled with this question. Was there truly nothing before the Big Bang? Or was our understanding incomplete? Recent discoveries, like the James Webb Space Telescope's observations of ancient galaxies, have challenged the idea that the Big Bang was the absolute beginning. These galaxies appear far more mature than expected, suggesting that the cosmos has a far deeper history. This has led some physicists to propose that the Big Bang might not have been the true start, but rather a transition from a previous state. In other words, our universe could be part of a much larger cosmic cycle, a story that goes beyond the limits of time itself. As we continue to explore, we uncover more clues that blur the lines between past, present, and future. But the question remains, if the Big Bang wasn't the beginning, then what was? Long before the Big Bang became a household term, scientists wrestled with the idea of the universe's beginning. But as our tools improved, so did our understanding, and new puzzles emerged. Around the 1980s, a revolutionary idea called cosmic inflation burst onto the scene. Proposed by physicist Alan Guth, inflation describes a brief but astonishingly rapid expansion of the universe, faster than the speed of light, occurring just a fraction of a second after the Big Bang. Why does this matter? Cosmic inflation helps solve some stubborn mysteries about the universe's large-scale uniformity and structure. It explains why distant regions of space look so similar, even though they couldn't have interacted in the early universe. And it sheds light on how tiny quantum fluctuations could have stretched out to see the galaxies and stars we see today. But here's the twist. Inflation also raises questions about what happened before it started. The classical picture of the Big Bang singularity, a point of infinite density and temperature, doesn't hold up under quantum scrutiny. At scales smaller than atoms, quantum mechanics governs the behavior of particles, making the singularity concept less reliable. Physicists have been searching for a theory of quantum gravity, one that unites Einstein's general relativity with quantum mechanics, to understand the true nature of the universe's birth. Without such a theory, our picture of the singularity remains incomplete, and the beginning itself may be an illusion. Some new theories suggest that instead of a singular start, the universe might have emerged from a previous phase or bounce, a cosmic rebirth of sorts. This opens doors to possibilities like a cyclic universe, where expansions and contractions repeat endlessly. Even Sir Roger Penrose, a towering figure in theoretical physics, has proposed bold ideas challenging the traditional Big Bang narrative. He introduced the concept of conformal cyclic cosmology, which suggests our universe's future, when it becomes cold and empty, could be mathematically linked to a new Big Bang, beginning an entirely new cycle. These ideas push us to rethink time, space, and the very fabric of reality. They hint that the universe's birth might not have been a singular event, but part of a much larger cosmic rhythm. The journey to understand the universe's true origin is ongoing, with each discovery reshaping our cosmic story. And with new telescopes and experiments on the horizon, who knows what revelations await? Our everyday experience makes us believe that time flows steadily, moving from the past, through the present, and into the future. But modern physics shows that this sense of now is not as simple or universal as we think. According to Einstein's theory of relativity, time is relative. Different observers, depending on how they move through space, will disagree on what counts as now. For example, if someone far away in a distant galaxy is moving relative to us, their present moment might slice through time differently, even making events appear shifted thousands of years into our past or future. Time, it turns out, is more flexible than our intuition allows. This flexibility of time becomes even more fascinating when we consider particles of light, photons. Photons move at the speed of light, and from their perspective, time doesn't pass at all. They experience all moments simultaneously, past, present, and future. Building on these insights, Sir Roger Penrose developed the idea of conformal cyclic cosmology. This theory suggests that the universe doesn't just have a beginning and an end, but instead goes through endless cycles. Each cycle, or aeon, starts with a Big Bang and eventually stretches out into an almost empty state dominated by radiation like photons. Remarkably, Penrose proposed that the very remote future of one universe's cycle looks mathematically similar to the Big Bang of the next. So the end of one universe is linked to the beginning of another, an infinite series of universes, each born from the ashes of the previous one. This model challenges the traditional idea of a singular beginning and ending and suggests the cosmos as a continuous process of rebirth. Eternal inflation and the multiverse. Building on our understanding of the universe's cycles, let's explore another captivating concept: eternal inflation. This idea emerges from combining quantum physics with gravity, revealing that the universe's rapid expansion after the Big Bang, known as cosmic inflation, might never truly stop. Instead, most of space keeps inflating forever, with tiny pockets where inflation slows down and bubble universes like ours emerge. Imagine the universe as a vast cosmic ocean, where bubbles keep forming endlessly. Each bubble might have different physical properties, even different laws of physics. This idea leads to the concept of a multiverse, an infinite collection of universes, each one a separate bubble. The multiverse concept suggests every possible event, outcome, or scenario might happen somewhere out there, given infinite possibilities. Our universe, with its specific conditions that allow life to exist, could be just one rare bubble among countless others. This fascinating theory also raises deep questions. How do we test or prove the existence of other universes? And if the multiverse is real, what does it mean for the uniqueness of our own universe and our place within it? However, some recent observations have cast doubt on the simplest versions of inflation theory. For example, in 2014, a team called BICP2 thought they found evidence of gravitational waves from inflation. Later, it turned out those signals were caused by dust in our own galaxy, not cosmic origins. This setback has pushed scientists to reconsider and refine these ideas, looking for new ways to understand the very earliest moments of our cosmos. The Big Bounce and cyclic universe theories. While the Big Bang and eternal inflation theories dominate cosmology, alternative models like the Big Bounce offer a different view of our universe's origin and future. The Big Bounce theory suggests the universe didn't start from a singular explosive event, but rather undergoes a series of expansions and contractions, like a cosmic heartbeat. Instead of emerging from nothing, the universe contracts slowly until it reaches a very dense state, then bounces back and expands again. This model challenges the classic idea of a one-time beginning, proposing that the universe's smoothness and flatness arise naturally during these periods of slow contraction, without needing a random quantum event like inflation. Importantly, the Big Bounce theory predicts a universe without cosmic gravitational waves generated by rapid inflation. That means ongoing and future experiments searching for these waves could confirm or rule out this model. Alongside this, the cyclic universe concept extends the idea, envisioning the universe as endlessly cycling through bounces, expansions, and contractions, each cycle giving rise to a new cosmic era. This cyclic view offers an elegant solution to some puzzles of the Big Bang theory, suggesting that our current universe is just one phase in an eternal cosmic rhythm. Scientists are actively testing these models, using powerful telescopes and detectors to observe cosmic microwave background radiation and gravitational waves, hoping to unlock the universe's deepest secrets. The future of our understanding. As we dive deeper into these groundbreaking theories, the Big Bang, Big Bounce, eternal inflation, and cyclic cosmology, we find ourselves at the edge of our understanding. The universe, it seems, might not have a simple beginning or an absolute end. Instead, it could be part of a much grander, possibly infinite, cosmic cycle. If the multiverse idea holds true, our observable universe might just be one bubble among countless others, each with different physical laws or histories. This means what we call nothing might actually be a gateway to infinite possibilities beyond our perception. On the other hand, if the Big Bounce model proves correct, we could learn that our universe is unique and eternal, cycling through phases of expansion and contraction, governed by deep physical laws yet to be fully understood. Upcoming experiments and observations, searching for cosmic gravitational waves, mapping the cosmic microwave background, and testing quantum gravity theories will be crucial. These will help us piece together the true story of the cosmos, shedding light on how the universe emerged from nothing or perhaps from something even stranger. In this grand quest, the question, who created nothing, might evolve into what is the nature of reality itself? A question as profound as the universe is vast. Thank you for joining this cosmic journey into the mysteries of our universe's origins. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more fascinating explorations into space and science. See you in the next video where we continue to explore the wonders beyond our sky.